In this problem, I have some information, and based on those information, I want to identify what was the sample size. I have two information about the sample, standard deviation 43 and average 86. I have some information about the gap between upper bound and lower bound in the interval, and I have some information about the confidence level. Let's first talk about this and see what does it mean. Says I have a normal distribution. I have computed the interval for 96%, and this interval from lower bound to upper bound is equal to this. So I have this gap, which is 44.1556. Now the question is what this gap means, or indeed what this point means in standard normal distribution. In other words, if I have this information, this 96%, can I identify this point in standard normal distribution and clarify how many standard deviation is it to the right? Because if I find how many standard deviation is it to the right, then it would be equivalent to half of this number. Or if I double this, it will be equal to this number. Therefore, for the time being, my problem is reduced to finding this point in standard normal distribution. If this area is 96%, then 1 minus 96% is 4%. Therefore, I have 2% here, and I have 2% here. Therefore, all the way from this point, all the way to negative infinity, I have a 96 and 2, which is 98. I want to find the z. This area all the way down is 96 plus 2, 98%. And that is very simple to find it. As soon as I find it, that tells me you should have gone this many standard deviation to the right. And that many standard deviation to the right is half of this number. So if I find z of 98%, and if I divide this 44 by 2 and set them equal to each other, in that case, I will be able to find the standard deviation of the average. Because this distribution is the distribution of the average. I had 96% here, 2% here. I found it out that for this point, I need to find z of 98%. That z of 98% tells me how many standard deviation have you gone to the right, and that how many is equal to half of this number. Equal to norm inverse, norm standard inverse. So if I give you the probability, what would be the z? And for 0.96, which was my interval, plus 2%, which is still on the left, which makes it 98%. Enter, and it will tell me, look, if you want to have 98% here, then you should go 2.05 standard deviation to the right. So I have that. But at the same time, my problem tells me the gap between lower and upper is 44 point something. This is the number that I had. This is the number of standard deviation that I should go to the right, but this 44.1 something is from here to here, the distance between these 2 points. So if I want to find the distance from average to the right, I should divide it by 2. Here I have a dot also over there, remove it, equal to this divided by 2, which is 22 point something. And now that is 2.05 standard deviation. If I divide this one by this one, I will have the standard deviation of the average. There is a simple relationship between the standard deviation of the average and the standard deviation of the sample. Standard deviation of average is equal to standard deviation of sample divided by square root of n, where n is the sample size. Now I do have this one, which is close to 11. I do not have this one, and that is what I am looking for. But I also have this one, sigma. If I go back, sigma of the sample is 43. Therefore, all I need to do is to type here 43, and I know that this 43 divided by standard deviation of average is square root of n. So I'll go here, 43 divided by standard deviation of the average is square root of n. And therefore, all I need is to say equal to 4 squared, and that is 16, the sample size. So what we did, we had 1 minus alpha, which was confidence interval, 0.96. If this is 0.96, then the whole area all the way down is 0.98. And therefore, we added that 2%. We got it 0.98. In the z distribution, if this probability is 0.98, what is this point? And it tells us 2.05 standard deviation to the right. Then we had in our own distribution, we had the gap between upper limit and lower limit was this much. So half of it is what I have gone to the right, or twice of it is equal to that. Gap between upper control limit and lower control limit in z distribution is 4 standard deviation, and in our data is 44. Therefore, 44 is 4 standard deviation. We divide them by each other's and we get something close to 11. We divide them by each other's and we get 10.75. Now we have a relationship between standard deviation of average and standard deviation of x, standard deviation of a random variable. If the standard deviation of random variable is 43 and n is the sample size, then the standard deviation of the average is equal to standard deviation of the sample divided by square root of n. That one is 10.75. This one is 43. We get 4 and then square it and we get 16. I hope this can help. Look, I explained this procedure mainly to help you to understand what is behind standard deviation of a random variable and standard deviation of its average. When we average things, variability goes down compared to the variable inside the sample. If variability of the variable inside the sample is measured by sigma, whatever it is, variability of average of those random variables is much less. It is sigma divided by square root of n when n is the sample size. And then I also wanted to know that what confidence means, and so on and so forth. But now you may hate me because I'm going to also show you a very simple way to do the same things. And you may say, oh, Dr. Asif, you wasted my time. I spent 10 minutes to understand it. That is good. You need to have that understanding. But right now I'm going to show you a very simpler way to do the same. Look, this is the same problem. Confidence level 1 minus alpha, average, standard deviation of x, the gap between upper limit and lower limit. And we know that the gap between upper limit and lower limit is twice of the margin of error, because we need to go that much to the right and that much to the left to cover that confidence level. So if I divide it by 2, that is my margin of error. And n, we don't know. We want to find an n such that the margin of error of the variability in the average of the sample does not exceed 22.07. Now let me show you what trick I'm going to use. Here I type 1 and here I type 100. You can type anything else as long as the first one is small enough and the second one is large enough, equal to this one. And then equal to this one plus this 100 and lock it, because I'm going to copy it down, and then you may copy it down as long as you want. Confidence norm, what is alpha? 1 minus, and I should lock it because I'm going to copy it down. What is the standard deviation? Standard deviation of the sample, not that of average. It's set and I lock it. And what is the sample size? The sample size is this one and I don't lock it. Enter. It is 88, but I want it to become 22, right? Therefore, I want the difference between that one and 22, and I lock it, to be equal to 0. Because I want that left-hand side to be 22. It is 66. Now I copy it down. I see that when I went from 1 to 101, my contribution margin minus what I want went from positive to negative. I am looking for 0. Therefore, what am I looking for is between 1 and 101. I will go and I change this 100 to 10. Now everything is fixed. Again, I go down. I see up to 11, it is positive. At 21, it gets negative. So I'll go and change this 10 to 1. Then I go down. I see at this point, it gets almost 0, 3 zeros. So my sample size is 16. Let me show you one last technique equal to confidence normal. What is your alpha? 1 minus this. What is your standard deviation? This is my standard deviation. What is your sample size? This is my sample size, and enter. Let me enter 1 here. This is my sample size. Now I need an estimate. For example, I may enter 100. When I enter 100, this becomes 8. When I enter 1, it is 88. If I go here and I subtract this one from this, when I enter 1, it is positive. When I enter 100, it is negative. If it is not negative, then I go and enter 500. And I find a number such that this one becomes negative. Here, when I entered 100, it became negative. I'll go to solver. Solver, please look at this number. Make it equal to 0 by changing this number. And then I should use evolutionary algorithm. This is not an exact algorithm, an algorithm which ensures that it will give you optimal solution, the best solution, but it gives good numbers. In many cases, optimal solution, at least for simple problems like one we are dealing. I changed this one, I made it evolutionary, but evolutionary algorithm needs some bounds. Our n definitely is greater than or equal to 0. We know that sample size cannot be negative. Okay, and sample size should be less than or equal to 100 because I know it's less than or equal to 100. I enter it and then I say solve. It takes some time. It's not very fast algorithm. Compared to this one, the second approach is better and easier, but I just want you to know this one too, that you can always use solver algorithms. Okay, it found a solution for us, which is close to the solution that we are looking for. Both 16 and 17 take us to the result that we want. Thank you very much for your attention. So we really like to learn a little bit about the foundations, understand those, especially a feature that we need to remember that when we average things, when we add things to each other's, variability in the results will go down because up and downs will compensate for each other's. Thank you very much for your attention. I hope you all reach to the point that we desire and that we deserve. Best wishes for all young, hard-working students.